Greetings, Dr. McNair. Welcome to my part of the group project presentation demonstration. Our project focused on implementing dense wireless sensor networks in OMNet++. The main goal of our project was to investigate broadcast protocols and wireless sensor networks, and we were going to simulate a sender-initiated broadcast algorithm. To do this, Yoon is going to talk about how he implemented a approximate neighborhood location awareness protocol in MATLAB, and my focus was on actually implementing the wireless sensor nodes in OMNet++, which is a very powerful simulation tool, and generate essentially a wireless sensor node model and have some OSI layers and a hierarchy. And my focus on implementing the layers is just on the essentially MAC layer in layer 2 and the network layer in layer 3. I'm going to run everything from the application layer, and I need to set up the layer 1 physical layer in OMNet. I kind of scaled down the focus of the amount of nodes to simulate, had some problems to overcome, and we're going to compare the performance of flooding and various ad hoc broadcast protocols. Let me get right into it. So the first thing to do was develop my model for a wireless sensor node. To do that, I used a essentially toolbox like a MATLAB called Mixum. And what this allowed me to do is they had various blocks that I could throw in here for the different OSI layers. I chose to implement their physical MAC layer interface, network interface card essentially, and I'm going to develop a custom network protocol and bypass the other layers and just essentially start broadcast and manage everything at the application layer. What this has allowed me to do is determine which node index is my sender and who's my destination just based on essentially node 1, 2, 3, 4, 5, 6, 7, 8, and 10. I'm going to select node 0 as my source and node 1 as my destination, and everybody else is just going to be an intermediate node, and we're going to go from there. In order to do that, I needed to develop my simulation environment, and this is where the connection manager kind of controls the various physical layer connections between the different nodes, where we can set the number of channels to use, what channel number, the frequency, etc. And our world manager here kind of simulates the environment that we're simulating in. Do we want obstacles? Do we want to model free space? Do we want the path loss? Or some interference from something, noise levels, that can be all configured in the world. Speaking of configurations, everything is done in essentially a configuration file where, like I show you here, different channel parameters, different physical layer parameters such as the transmit power and the noise level sensitivity of every node. Again, this can be configured either a configuration file or in real time during the software. This can be changed. Do I want to implement increase my transmit power, and you can model battery life, and that makes OMNet a really great tool. And a couple MAC layer parameters I wanted to point out was the essentially number of packets that can be held in a queue. I just arbitrarily chose this as 5. I'm sure if I chose this as 10, it would affect things, but I picked a number with it. Bit rates and transmit power again, and various other parameters such as the contention window and backoff methods, which is going to be changing in my software. Getting into some of the code that I was able to develop, where I kind of pulled some of the examples from various Mixum applications. And here's my first level application layer, where I'm just going to say, hey, if I'm node 0, I'm going to be the sender, and I'm going to broadcast to a specified destination of node 1. And we're going to handle different packets a certain way and broadcast them. And then for my network sensor layer, since I have a couple different architectures to implement, the first thing I wanted to do is just implement a DOM network layer. All it's going to do is receive a packet, determine if it's for this node. If it's not, we're going to rebroadcast it out. Don't really care who it goes to. It's just going to flood the whole the network. The next, I just added a little bit of intelligence where it determines, is this node, who's this going to? If it's not for me, did I send this packet back out? If I didn't resend this packet back out, I'm going to rebroadcast it or just choose to ignore it and drop it altogether. And once, the packet time of life expires, we're just going to drop the packet and so we can kind of free up some of the congestion in the channel. And then I added a little bit more intelligence and made a smarter network layer where I'm actually implementing the ad hoc broadcast protocols and determining, setting the number of hops that this guy can transmit to, and handle different data and app packets, and setting up routing tables and everything in my other wireless sensor network layer. And to run the simulation, I kind of created a couple different configurations in this file, and we are going to boot them up and build them. So I'm going to run as the OMNet simulation. It takes a second. And the first thing I'm going to demonstrate for you is just the basic broadcast, where we're going to flood the network and rebroadcast everything we get. So we're going to start off by node 0 is going to be our source, node 1 is our destination. Node 0 is going to send a packet after everything gets configured. As you can see, data is starting to go from node 0. The packets within range, which is set by the circles here, are going to pick them up and rebroadcast them until it gets to node 1. Once node 1 gets the data, here it goes. It's going to acknowledge it. Maybe not, that's in the next level. And what's going on inside node 1 is once it gets the data, it sends it up. Application is like, oh, okay, it's for me, thank you. And we're just going to do this back and forth. And there goes the reply. And what's great about Mixem is you can see all the different parameters going on in the background, everything at the different layers, and then the data going back and forth. As you can see, we have a reply from node 1 going back to node 0. And I noticed the whole cycle of what happens here, since we're just rebroadcasting all the packets. All the nodes essentially get the data from node 0, and they're just kind of flood the channel with these rebroadcasts until the packets expire. And then node 1 gets its ACK essentially back to node 0. And this cycle goes back and forth, and just the whole channel is flooded. So I'm going to speed this up. Kind of show you everybody's kind of rebroadcasting, dropping old packets as the time of life expires, or the maximum number of hops expires, excuse me. And not many packets are actually going back and forth between node 0 and node 1. So we're going to conclude this simulation. And I'm going to rerun it again. And this time we're going to implement the ad hoc broadcast sender initiated broadcast protocol, where again node 1 is going to start everything off. Let me just kind of run it. He's going to send packet 1. Everybody's going to rebroadcast, but they also start to develop kind of like a routing scheme, like who is the most efficient path to node 1. And so you can see data is going back and forth. Certain random back-offs are occurring so that we can get the packet faster to node 1 and not just have everybody rebroadcast. As you can see, node 1's already received it. And it started to generate an ACK. I'm going to speed this up for you, and you'll see that a lot of these rebroadcasts stop as, node 0 and all the nodes get, who's within range. Okay, I don't really need to send to you anymore, and develop an efficient path to node 1. So you can see all the rebroadcasts. Okay, we're dropping. Takes a minute, and then eventually it sets it up. Okay, and then we start to generate more packets back and forth. Let me slow that down, kind of show you that interaction. So node 3 says, hey, node 6 is my neighbor, let me send it to him. Node 6 sends it to node 1, and then we're going to start sending ACKs back and forth, and boom, he's going to acknowledge it and send the next data packet, and this ping pong back and forth is going to go. Let me speed up the simulation once again to kind of show you the end. I set it up to send out 100 packets, and we'll see how many we receive. As you can see, it's moving a lot more efficiently than just a simple broadcast. And that's about all. And as you can see, we set up kind of like a next hop neighbor. And let me kind of show you this here. in this table printout at the end, where node 1 determines, hey, my best hop destination is node 3. So he goes to node 3, and then node 3, if we go to him, he determines, oh, my next hop is going to be, excuse me, I'll find node 3. Node 3 determines his next hop is going to be node 6, and then node 6 is going to determine, oh, I'm close to node 1, and you see that, boom, node 1, node 3, back and forth, boom. And then, so they set up this whole routing protocol, and packets get through a lot more efficiently. And I guess we'll discuss the results during our conference call-in. Thank you very much, Dr. McNair, and we will talk to you soon.